Good morning, grade 12 physical sciences learners. The third topic under chemical equilibrium is to determine the equilibrium constant Kc. Kc is determined by using concentrations of the species in moles per decimeter cube. From grade 10 and 11, concentration is the number of moles of solute per cubic decimeter of solution. Concentration is equal to number of moles over volume. C is equal to N over V. Then the units are the moles per decimeter cube. Let me start this topic by working out a problem. A mixture of 1 mole water vapor and 3 moles carbon monoxide is placed in a container with a volume of 1 decimeter cube, full stop. The temperature of the container is 986 degrees Celsius. Equilibrium is reached in correspondence to the following equation. 1 mole of water vapor at gaseous phase reacts with 1 mole of carbon monoxide at gaseous phase, forming the products of 1 mole carbon dioxide in gaseous form plus 1 mole hydrogen gas. This is a reversible reaction. At equilibrium, there is found to be only 0.32 moles of water vapor. Calculate the value of the equilibrium constant under these conditions. In this problem, you are given the initial number of moles, not given the concentrations, but required to calculate the value of the equilibrium constant. In this problem, you are given the initial number of moles, not given the concentrations, but required to calculate the value of the equilibrium constant, Kc. You have to work out the concentrations using a table. Set up the table according to the balanced chemical equation. 1 mole of water vapor at gaseous phase reacts with 1 mole of carbon monoxide at gaseous phase, forming a 1 mole of carbon dioxide at gaseous phase plus 1 mole of hydrogen gas. Make use of the template provided. 5 rows are provided, but you can include the molar ratio row. On the horizontal column, second row, is the initial number of moles. Third row is the number of moles reacted or reformed or used. Fourth row is the number of moles at equilibrium. Fifth row is the concentration. Concentration is the number of moles over volume in decimeter cube. It means the concentration is determined by the number of moles at equilibrium. Fill in all the information given. Information is as follows. The initial number of moles is 1 mole for water, 3 moles for carbon monoxide, CO. Number of moles at equilibrium. The water vapor is 0.32 moles. Water vapor is 0.32 moles. Fill in also the volume of 1 decimeter cube in the 5th row. Have a look at the template provided. Fill in all the blocks for the products, carbon dioxide and hydrogen gas. Fill in 0 number of moles. Initially in the experiment, there are no products. Number of moles reacted or formed by the water vapor is the link. Number of moles reacted or formed by the water vapor is the link. Think of the chess game. 1 mole of water as initial number of moles minus 0.32 moles of water at equilibrium will give you 0.68 moles of water used or reacted. So it's 1 minus 0.32 and you have a 0.68 moles. The number of moles in the balanced chemical equation applies to the number of moles used or reacted. Fill in 0.68 moles of water. According to the balanced chemical equation, 1 mole of water reacts with 1 mole of carbon monoxide to form 1 mole of carbon dioxide plus 1 mole of hydrogen gas. Therefore, the number of moles reacted is 0.68 for carbon monoxide, 0.68 for carbon dioxide, 0.68 for hydrogen gas. Calculate and fill in the number of moles at equilibrium for carbon monoxide is 3 initial number of moles minus number of moles reacted. Therefore, carbon monoxide equals to 3 minus 0.68. Then you have a 2.32 moles. Carbon dioxide is 0 minus 0.68, giving you 0.68 moles. Hydrogen gas is 0 minus 0.68, giving you a 0.68 moles. I don't mind the signs, I'm just looking for the difference. Fill in the number of moles at equilibrium. Calculate the concentration, which is the number of moles at equilibrium over volume of 1 decimeter cube. Therefore, the concentration of water is 0.32 moles per decimeter cube. Concentration of carbon monoxide, CO, is 2.32 moles per decimeter cube. Concentration of carbon dioxide is 0.68 moles per decimeter cube. Concentration of hydrogen gas is 0.68 moles per decimeter cube. Look at template number 2. Then you are required to calculate the Kc. Kc equals to the concentration of carbon dioxide in square brackets multiplied by concentration of hydrogen gas over concentration of carbon monoxide in square brackets multiplied by concentration of water molecule in square brackets equals to, then you put the values in brackets, equal to 0.68 multiplied by 0.68 in ordinary brackets over 2.32 multiplied by 0.32. Then the answer is equal to 0.46 over 0.74, which is equal to 0.62. Kc is less than 1. The equilibrium will shift to the left. The reverse reaction is favored and more of reactants will be formed. So the reactants are carbon monoxide and water molecule. Work out examples with different number of moles from your textbook and study guide. Thank you.